So to review my studying plan, just kind of lightweight software, 3 jobs per day, apply 3 jobs a day, and then study some hardware, and then the next, you'll be seeing some hardware videos where I kind of recommend resources on studying computer architecture, amongst other things, but also I want to talk about drinking water. It's quite important because even if you're very slightly dehydrated, your concentration and focus is going to exponentially decrease, and obviously that's not a good thing when you're trying to solve, fairly difficult puzzles, as we will now. So let's take a look at this problem. A peak element is an element that is strictly greater than its neighbors. Find a peak element and returns its index. You can imagine that it's okay. So basically, if this was 2, 1, because this is negative infinite, then okay. Okay, so all neighbors are gonna be different. Return any of the peaks. So 0, 1, 2, 3, 4, 5 is a peak. 2 is a peak. I see. It seems like a fairly straightforward. You must write an algorithm that runs in log of n time. Okay. I don't want to though. 3 is a peak element, and so y log of n, you don't, there's no order to this, right? So if I say, well, let's take a look at 3, it's not a peak, it doesn't really help me divide the thing into this. Even if I were to build a new data structure or something of that nature, then it will at least be of n. Like if, let's say this was not a peak, like let's say this was not a peak, and then it's like in this ascending thing. So it's either a valley or ascending or descending. If some element is a valley, meaning like 3, 1, 4, 2, and 3, then left or right can be, either of these can be peaks still. Oh, I see. I see. Okay. So that's why, okay, I see. So basically, if I imagine an array and these are like different heights, let's say, and then you can kind of look at this as like different jagged things of like, let's say a stock market. Then let's say this was, this one or this one. meaning it's not a local maxima. If it's not a local maxima, we just want to keep finding out the, we just want to go towards the increase. So for example, if I'm a 1 and I'm a valley, yeah, if I'm a valley, then I want to go left or I want to go right. It doesn't matter. And then there's probably some anchor. So for example, maybe I can just run an algorithm on this more complicated one. And then the length here is 7. So maybe, you know, left is 0, right is 6. And mid is like, let's say like that. So 0, 1, 2, 3, right? And then I would check its neighbors, which is gonna be 1 and 5. And so if I'm a peak, then just return, you know, mid. If I'm not a peak, go towards the direction of uphill. In this case, we know that the mid plus 1 index is bigger than the mid index, so you want to go that way. And if, let's say, the other way around, we go that way, because of this condition here, where neighbors are not going to be, neighbors are guaranteed to be unique, then we can just say something like we're always guaranteed that there's some number that's higher than our midpoint. And if there's no number that's higher than midpoint, then we're the peak anyway, right? So, but then if there's a number that's higher, then we just go towards the direction of uphill. So probably like, mid equals, between 3 and 6. So like right minus mid, so 3 divided by 2 int of that, plus mid, I guess. So this delta is 3, so 4, I guess. So we'll go here, and then it'll go and check and see that, hey, there's another uphill, and then it'll go ahead and then do this. So let's say this was your new mid, which is 0, 1, 2, 3, 4. This would be a 4, and then so 6 minus 4 is 2. And then so the last element you go here is this, and then you kind of check its neighbors, and then you'll find that, hey, neither number is higher. Then, go ahead and return that number. Now the edge cases, I almost want to just handle the edge cases individually. Yeah. So if then obviously it's a peak if the length of nums is 1. If nums 0 is greater than nums 1, then just return nums 0. And then likewise, if nums minus 1 is greater than nums of minus 2, so if after this case statement doesn't return, if it doesn't return, hold on. Yeah, let's run through this. So if it's a length of 1, then I have to be a peak, so return index 0. And then also if after this I'm able to make it through line 12, that means nums is of at least length 2 because of this, so that I can legitimately compare this. So if the first element is bigger than the second element, then go ahead and return 0. And then if the very last element is going to be bigger than this element, then go ahead and just return the final index, right? And then for the rest, we can go ahead and do this loop. So we can just say, well, left is 0, and then right is going to be the length of nums, in this case 7. And then so we're guaranteed to find a peak. So I just want to say while true, but you can also do like while left is less than right. Maybe. So this formula is saying like if we have a left, mid, and a right partition, and then the uphill is on the right hand side, like so, then we would update this mid like so. So this would go to here as previously discussed. But then the left, instead of 0, it should probably go over here. Or, yeah. And then I check the mid again and go here. Let's see, I mean, like, okay. And then if it's the other case, like going left, so for example, I have like factor 1 instead, and I want to go left, then maybe right is mid, so the right starts like here now, and then the mid is just gonna be the int of the left minus mid, divide by 2. It's suspicious actually. Is this the correct way to update? I feel like there's a better way. Mid equals right minus mid, which is the distance between, let's say, like this one and wherever the thing I'm checking is. So this is just half that distance, and then we do the half that distance for it, and then just plus the mid. So then we just end up somewhere here. Likewise here, we take the distance between, I guess mid will always, so for example here, and maybe if let's say we were doing 1, and let's say we're going left, then right would be here, just update it here, and then the mid will be this minus 0, which is 0 into 3 minus 0. This is 1 plus left is 1. So we go here. So then after first iteration, mid is 1, right equals 0 into 3, left is the same. But now mid is here, and then I'll want to run this again. Because it's on the right hand side. So yeah, so I'll do the detection where mid equals 1. I'll find that I want to go to the right. Then left equals 1, because then it will just update to this one. And then right right is not going to be changed. It's still going to be 0 into 3. And we just squeeze this mid here. Mid is just going to be equal to this minus this divided by 2. So 1 plus mid is 2. So 0 and 2. And then we're going to go ahead, next iteration, check it, and then find that we have the peak and return the mid. Alrighty. So that works for that. And then perhaps I also want to run it through this example after I write the code. I'll run through both examples again once I write the code, and then just to double check. Okay. So, actually length -1, because this would be out of bounds otherwise. So, mid equals this is just following this formula. So length divided by 2, which is 7 divided by 2, which is 3. And then now I want to basically check mid to see if I'm a peak or so. If because of this condition, if we get past this, this must mean that nums is bigger than 2. Because if nums was 2, we must have either the first or second element be the peak. So this handles the first element, and then this handles the second element. So if we get past here, that means that the length is at least 3 or above, meaning right is at least 2 or greater. And if this is at least 2 or greater, or this is at least 3 or greater, then that means the mid won't, start at 0, or like it won't start here and it won't start here. For length 3 or above, it has to be like we can always have a mid -1 and a mid +1 index to compare against. So at least that's my thinking. Yeah, otherwise, because the counterexample is like, hey, let's say I start here with the mid, and then I need to traverse to an edge where the mid's at an edge, but then the edges would have been taken care of here. So like it seems like the mids can really only drift to 1 or -1 of nums. Sorry, 1 or -2 of nums, like second to last and the second element of nums. So it can only drift that far just mathematically, speaking, because we already took care of the boundary conditions. And we're kind of guaranteed to have an answer because of this one. And then so if we go here and then we do it, then if we just can drift between the first and the second to the last element, then that means the mid always has a mid -1, mid +1 for the entire algorithm. And we shouldn't have to care about out of bounds issues. In the real thing, and perhaps in an interview, you might say, well, I will do PyTest and assert that mid is never 0 or length of nums -1. Okay, but you might just say that in an interview and then give yourself a little bit of leeway to take a little bit of shortcut. Let's see if this bites me in the ass. All right, yeah, so if nums of mid is bigger than nums of mid plus 1 and nums of mid is greater than nums of mid minus 1, then it's a peak. Otherwise, it's not a peak. If nums of mid plus 1 is num greater than this, then that means the right-hand side is bigger than our current thing. So go to the right. Go to the left, pass. So if I'm going to the right, we said that the left will be mid, and then the mid will just be the int of the right minus mid divided by 2 plus the mid, and then the right remains the same. Go to the left, then we would now say right is mid, and mid equals int of mid minus left divided by 2 plus left. Okay. By transient property, you will see that there's one of these must be true. So it's either I am bigger than both my neighbors, or one of my neighbors is bigger than me, right? Otherwise, if none of these are true, then that means at least one of my neighbors is equal to me, which violates this specification. I almost want to do while true, but let's just do this because it'll make for debug a little bit easier. So the bold thing I'm kind of saying is like we'll always end up in this case because of this. All right, so let's run through these two, right? So if I do this, then, you know, left, mid, right is just gonna be 0, 6, and 3. And then I'm gonna go and check 3, 6, and 0 less than 6, and then this is not bigger than this, so we can skip this. Mid plus 1 is bigger than mid. Mid plus 1 is just gonna be 4, 0, 1, 3, 4, so 5 is bigger than 3. So then update left to be now 3, and then mid is just gonna be the difference of this. So 6 minus 3, 3 divided by 2, 1 plus mid is 4, and then this is the same. So now 0, 1, 2, 3, 4, we're here for the mid. I guess it doesn't matter if we do an extra, like, so we updated these pointers and then like 5, right? So like, so I guess I'm thinking like if I should do else if, right? Like, and maybe it's a little easier to debug. Because without else if, you can say, well, I update these pointers here, but then I also, do another iteration. But for clarity's sake, maybe I just do it like this. All right. So 3, 4, 6, and then 4 is just gonna be comparing, so 0, 1, 2, 3, 4, so mid minus 1. So if we're here, then we'll say, well, it's again this. This isn't gonna be, 5 is not bigger than 6, but 6 is bigger than 5. So again, we would just say left, mid, right is gonna be equal to left, mid, right is going to be equal to this, and then your mid is going to be the right minus mid divided by 2 plus mid. So it's just going to be a delta of 2 divided by 2, so 1 and then 5, and then 6 is the same. So 0, 1, 2, 3, 4, 5. And then in the next iteration, we will find that this is bigger than 6. So 6 is bigger than 4, and 6 is also bigger than this, and then return it. And then also, if we did this instead, we also start out here, so 0, 1, 2, 3, except now we would want to go to the left, because mid plus 1 isn't bigger than 3, but this is bigger than this. So here instead we would have the right equals to the mid, and the mid is just gonna be 1 plus 0, and then left is unchanged. And then in the next iteration, we're gonna look at this, and we're gonna want to go to the right, which I think I already calculated here, but let's just calculate it again. It's gonna be, so the left is mid, so like this, and then the delta is just gonna be 1 plus mid, so 2, and then right is 3, and then we're here, 0 and 2, and then here we just return because of this condition. And then let's also do 1, 2, 3, 1. Over here, 1, 2, 3, 1 would have the length is 4, so 4 divided by 2 is 2. So over here, and we would already return it as a peak, but let's perhaps do it like that. So we have a little bit more iteration. So here we would want to go to the left, because this is bigger than this, but this is not bigger than this. And then so yeah, 1 is not bigger than 2, and then but 3 is bigger than 2. So then we go ahead and say, well, okay, right equals the mid, and then the mid, so 0 is the same, and then what is the mid? Mid is just going to be the delta between these two divided by 2, which is going to be 1 plus left is 1, and then we just go here and then we return. Okay, I think running through those manual examples, we can start the whole debugging process, and perhaps we can just okay, let's, all right. Given string S, check if it can be constructed by taking a string of it and appending multiple copies, and appending multiple copies of the substring together. So one of the things is like, you can't have, so is it true that the first n characters or your prefix must be the substring? So like pattern, pattern, pattern in like a perfect modular manner. So for example, if I have a prime number of characters, you can't really do it. But I guess, I mean, that's just an observation. You wouldn't use that as a necessary and sufficient condition. Like, is there a case where you could have like X pattern, pattern, and then X? I mean, that's a palindrome, but then you can't, right? Like, because then if, let's say you do this, right? Then the first n characters is still the pattern. Like here, it must be talking about ABC. You can't be talking about like cab, cab, cab. You know what I'm saying? Like the ordering and the sequence matters a lot. Okay, so that's an observation. When you say substring, like, you know, you could say you can arbitrarily pick a substring at anywhere in the string, but it's kind of a moot point. You can always encode it to be the first n characters. Because if it's not the first n characters, like if you, yeah. Basically, I guess the thing is like, can I kind of tile it perfectly and then can I make the simplification? Now, yeah, I just check the first n characters. 10 to the 4 is 10,000. And I feel like there must be a speed optimization here. Like for example, if my plan was just to say, all right, let me check A. Is this equals to, you know, A times however the length of the, you know, S is? No, okay, let's do AB. And then so we would check 10,000 times. Like if AB, right? And then like ABC, right? I guess it's 10,000, but then I could stop this loop at half, because if I don't find anything at half, like if, suppose I have a string of like 8 characters, right? Let's say I do A, B, C, D, E, it kind of doesn't matter after this, because if I don't find anything at this halfway point, then I can't stamp it another time. So that is another kind of like split in half. So like I would only maximum need to run 5,000 iterations. Which, okay, fair enough. So let's say I do a loop. I start at 1, because here, for example, ABA, I would want to do like 1 of 4 inclusive, aka 1 through 3 inclusive. So then when I is 2, I can already quit. Here it's like you have one shot, right? Because like if you even, yeah, like you can't, if you're over it, like if, So 2 is going to be bigger than the length of s, which is 3 in this case, divided by 2, 1.5. 2 is bigger than 1.2, so we can return. Now, if it's equal to this, then there's still a chance, you know? So that's the speed optimization. And so in this case, you just start with A. I'll just do this because I use it so much. So if n divides into I, then replicate per substring and do stuff. Else continue. Like for example, if this was ABCA, this 12 actually is a bad. So let's say this was 5, like this. Well, I can't stamp 5 evenly into this thing anyway, so just pass, just continue, you know. So I only even want to bother building the string and wasting time if it divides evenly. Okay. So how do you replicate a string? So I know I divides into n. So for example, you know, I is 1 and n is 3. So I just replicate it 3 times. So like 3 divided by 1 is 3. Even though it's an even number, I don't know, like, yeah, I might need to just int it. And then so if string to test equals s, then you know, return true. I guess the thing I'm not too sure of is like if this works like this. Python multiply string. Okay. I am guessing it doesn't matter if 2 times or times 2. I like it like this, but if not, I can just put this before. That shouldn't matter. All right, let's run through this. So n is 4, so this is gonna go through 1 through 4 with an exit intent at 3. So I is 1, so 4 divides into 1. So this would have A, because 0 exclude 1 is A. You know, replicated by 4 divided by 1, which is 4 times. So A is not going to be equals AB, so we just continue. And then the second thing, in the second iteration, I is 2. 2 is on the border, so it's equals to n divided by 2, but not greater than, so we keep going. 4 does divide it by 2 equals 0. So then 0 to 2 excluded is going to be AB. 4 divided by 2 is 2, so AB times 2 is AB, AB. So string to test, we should actually just return true, and then we're good. Okay, same thing here. ABA maybe is going to be 1 through 3 inclusive. So this one, again, we start with A. 3 divided by 1 is 3, so AAA. AA is not equal to S, so we would just go ahead and continue. And then in the second iteration, N is actually 3, so 3 divided by 2 is 1.5. 2 is bigger than 1.5, return false, we're done. And then finally, for this one, we can say, divides. It's not all A, so you go to the second iteration, and then we do, this is 12. 12 does divide into 2, so 0, AB replicated. So 12 divided by 2 is 6, so AB times 6, so AB, 6 times, not going to be equal, so keep going. And ABC is going to be 3. Does this divide into it? Yes. 12 divided by 3 is 4, so we just multiply this 4 times, and then it will equal, Here we don't have to worry about this not returning anything, because eventually, because of this loop's construction, we're going from 1 to n plus 1. I don't think there's a case where we never hit this even at, that. Maybe except for, let's do n equals 1, n equals 2. If n equals 2, then this would be 1 to 2. And basically, 2 divided by 2 is 1. 1 isn't greater than 1, so then they would just replicate it twice and just test it once. In the second iteration, it'll just say, well, 2 is greater than 1, so return false. And then what about for 1? Yeah, if, go ahead and just return true. Or, well, is it true? Yeah. Multiple copies, so false. Like, tautologically speaking, it is a substring, but like, it's not multiple copies, it's one copy. So, yeah, okay. All right, finish the session. A little long. I think the peak element one was just a longer because I really wanted to be anal and double and triple check and quadruple check it, to make sure the indices aren't wrong. Because with that, with the control logic with like plus minuses and proving out that the mid is like, mid plus 1, mid minus 1, you're not going to go out of bounds. That is that's kind of like the annoying thing. But I believe I need to go back. I don't think I had a single bug, which is kind of what I'm aiming for. And then if I can, like all these are very few bugs, so I might like start going a little bit faster incrementally. So then I can write high quantity as well as high quality code. But I think, like I said, just a little bit of software, but mostly going to be hardware. So I think the next few videos are just going to be me reciting computer architecture and coming up with Verilog problems and or Googling Verilog problems to solve. I hope you enjoyed this one. Drink water, drink probiotics, stay hydrated, and see you in the next one.